Welcome everyone to the special Udacity webinar today on ethical engineering and artificial intelligence. We're really happy that you're joining us today from wherever you are. Every country in Europe, I think, is represented, and also from around the world. We've had over 600 signups for this webinar. I'd like to thank you all for submitting your questions in advance. And I'm really excited for this webinar because it's the first we're doing in the series and with a new partner. And we have an expert panel lined up for you today. We are hosting this webinar in cooperation with the Good Technology Collective. The Good Technology Collective is a new European forum for piloting and discussing the technology advances of the 21st century. It was founded in Berlin in 2017 by a group of technology entrepreneurs, journalists, and technology enthusiasts, and they seek to foster a constructive conversation around frontier technologies, and in particular, the ethical challenges that they pose. So we're really happy to be partnering up with them today to bring you this webinar on ethical engineering in artificial intelligence. Very briefly on the format of the webinar, I will be handing over to our moderator, Dana Sheehan, who is the curriculum lead for robotics at Udacity. She'll be introducing the panel and giving a brief overview of what we'll be talking about today. And then we will have a panel discussion with the questions that you submitted in advance that we have organized into different areas. And then we will open up the discussion for a live Q&A as well. So I will be following along into different live Q&A in the YouTube live chat. And in order to submit a question, you have to have a channel on YouTube. So just go ahead and create a channel up in the top right if you do not have one yet. And then I'll be selecting the questions, and then we'll be feeding them to the panel. So without further ado, I would like to hand over to our moderator, Dana Sheehan.
Thank you, Chris. Go ahead and introduce our distinguished panel today. First up, we have Jan Lorratai. Jan is a French-German tech entrepreneur who started programming at age 10 and building electronics at age 14. He is a co-founder and the CTO of OneAIM, a full-stack AI building platform aimed at redefining how buildings work, as well as how we relate to the objects around us. Jan is also a founding member of the Good Technology Collective, where he focuses on rational data collection, greater public awareness of data gathering and use, and the importance of around the Internet of Things to one based on the concept of intelligence by design. We have Eduardo Pere, and Eduardo is an industrial engineer from Barcelona. He started his career as a researcher at the RWTH Aiken, and then worked in industry while teaching himself about rapid prototyping, IoT, and data science. He's always had an interest in building things, and his latest creation is AI Scope, an open source smart microscope that using computer vision technology to diagnose 3 of the world's deadliest diseases, malaria, tuberculosis, and intestinal parasites in remote areas. Next, we have Alan Mosca. Alan is the co-founder and CTO of NPlan, a startup that uses deep learning and AI to improve the outcome of construction projects. He's also a part-time doctoral student at Birkbeck, University of London, and also an alumnus of Udacity's Data Analyst Nanodegree program. Previously, he worked in quantitative finance at Jane Street with Wadhwani Asset Management. Welcome. It's nice to have you all here.
Thank you.
Okay. First of all, I'm going to go ahead and before we get started, I'm going to go ahead and frame the discussion. This is a rather new topic, and likely we'll have more questions than answers today. But we want to begin the discussion of talking about engineering and ethical AI. And what we want to ask is focus on what can we as engineers do to be responsible custodians of the technology. and a bit of an overview, just in broad strokes. Today, we want to think about the ethical challenges that exist in AI, the AI space today at the engineering level, and what are the most challenging problems we might face in the future. There are many examples where engineers are directly involved in data sets and algorithms that affect the welfare of the public and individuals in many ways. Some of the examples we might think of are machine learning training data, what biases exist in that data, autonomous vehicles and the decisions they make, and how are those decisions developed, social credit scores, such as we're seeing today in China, and in general, privacy and security considerations. Are we being robust in those as engineers as we develop our AI projects? So with that in mind, we'll go ahead and jump into some questions. First one is, what are some examples of AI being used for good? One thing we might look at is, something was said by Eduardo about using ML and networks to fight malaria. What are some of those things that go on? Are there some examples there?
Yeah, actually, let me answer a bit your question. There's a lot of projects that are doing amazing things with machine learning or AI to solve big problems. Like, for example, there's these things to predict who is having a depression. And it's amazing how those things are going to be working in the future in 5-10 years, where imagine kind of bots going all over the internet and diagnosing people if they have depression before they know it. Or things like this. It's just brilliant. I love it, just to predict which areas are going to be dry or which areas they're going to have water in the future. That's the brilliant part of AI. It's really something really promising for the future.
I think on that note, there's some effort that Facebook has been doing for a while now on trying to identify people that might be at risk of committing suicide, and they flag internally these profiles. Another thing that I'd like to bring attention to, which is a little bit close to my heart, is there's some research that's been done at the University of Southern California for automatically identifying from drone footage possible poachers of both rhinos and elephants. And there's lots of other examples of things like this, where all of this technology that we're developing is actually being focused and used for good.
You have any ideas or comments, Jan, on that subject of AI? Okay, well, we have questions here. One question that maybe, go ahead, Jan.
You just spoke up for me for a second. So I think you were asking if I have examples. I think if we look at the last decade, basically, we have seen the information of explosion. Like every 2 years, basically, the amount of data we have is doubling. And while we're also seeing negative effects, of course, the only reason we're able to navigate in the world today is because we have systems that filter that data and present us, like a slice of the world at a time. And I think that's been incredibly powerful in terms of making society more global and giving us new tools to work and live.
Thank you. What questions should engineers be asked to ensure the development of ethical AI and devices of your own where this has come into play? We'll start with Eduardo.
Yeah, I think the biggest question that we should ask ourselves is if we are bringing the world or the people further. So at the end, for example, going back to the typical question of autonomous cars, cars will have accidents always, definitely, for sure. That will always happen. It's a pity, but it will always happen. But we need to count in numbers if that's going to bring us to a better position. If we are having, I don't really know worldwide how many accidents we have, but let's say 1 million, and just having autonomous cars, we have 100,000. It's not 900,000 people that we save afterwards, we definitely need to do this ethical question of who are we killing. That's something that we do need to ask ourselves. But the first question is if we are doing things for good.
I think generally well, I'd like to preface this a little bit. So if we look back at what is happening today, or if we look back at the last year, for example, has been incredibly tumultuous, right? We have these incredible advances like self-driving car technology, Google with deep learning suddenly achieving tasks that weren't possible before, right? But then they're so tumultuous, right? Fake news have been everywhere. You know, people talked about filter bubbles for years and years and years, and now suddenly everyone is really feeling the effect of that. You know, we have governments who basically want to introduce pre-crime now and use machine learning in a way that is very negative. So I think the main question we have to ask ourselves in today's time is, how does it come that we have such a disconnect between the good and the bad, and it all seems to come from the same place, right? And that is actual engineers, you know, writing these algorithms, working with the data sets. And the crazy thing is, you know, they work at the biggest companies in the world as part of this huge ecosystem, right? And still somehow it seems no one really knows in advance whether what we are building, especially in like AI and machine learning, will have a positive or negative outcome. And I think the main reason is that no one is actually asking that question, right? As engineers, we are always, you know, driven by the challenge. You know, no one asks like, should we do this, but rather, can we do it, and then can we be the first, right? It's kind of in the nature of the engineer to strive for kind of the perfect solution. I think the issue we are seeing now, though, is that we are suddenly applying these technologies on an absolutely massive scale in society, right? And if you do that on a massive scale, you have unintended consequences really easily, right? If you introduce biases in the wrong area, it can affect huge portions of the populations, and also business and economics, of course. So what we in the GTC believe is that we need guidelines and rules, but we have to make sure that they're applied you know, by all stakeholders, you know, not just the legal team, because that's what happens today, right? We feel like, oh yeah, well, the legal team will take care of it, and then we can publish it, right? From the very beginning of working on a project, we just have to take into account what is the long-term impact if my technology would be applied on a massive scale. And I think it's especially important for people who work like in smaller companies and startups, because what they're building one day might actually be applied on that scale. And then a couple of years down the road, they'll be like, oh shit, I didn't expect that to happen.
I think that there are quite a few parallels with the development of other groundbreaking technologies. Like the example that keeps coming to mind to me is the Manhattan Project, where like even if you could have the best intentions in the world in developing nuclear fission, like ultimately, I think it's also down to the engineers to know not to develop things for the wrong purpose. And as much as we like to call ourselves purists about just doing the engineering work, you always have to think about the scope in which it's being applied. And I think that's very important. I am an optimist in this sense. So the great example is Google employees rebelling to Project Maven. And I think that's a great example of social responsibility by engineers in ML and AI of the purposes of what's being built.
Thank you. Well, about these guidelines, are there some kind of metrics to measure what is ethical and what isn't? How can we decide what is and where the line is for an engineer?
Yeah, I think for this thing is actually what Alan just said, that engineers need to be the ones that knows what is good and what is bad. I don't totally agree with his opinion of the Google, because it's amazing that Google engineers resigned, but it's horrible that they had to resign, so that they were someone behind that wanted to do this project. That's something that creeps me out a bit. That's a bit of a tricky thing, but there's definitely not KPI or something like this that we can apply, because every area of AI, it's so different that we just need common sense, and maybe some kind of control. I don't like to control is a horrible word. Regulation is even worse, but we do need to have something to make sure, like, for example, right now, Google, Facebook, Airbnb, all those companies, Uber, they have so much data about us that their algorithm can know way too many things, way too many things. They can predict so many things, but it's crazy. So for all the people that are listening now, that they must be, they must already know or must be learning machine learning. They know how kind of easy it is to predict things. It's not rocket science. So maybe from the outside it looks super difficult, but it's definitely not that hard. So those guys with thousands of engineers, with tons of data, it's dangerous. So they must be aware of what they have. It's almost like nuclear power what they have. So they must be really aware and have common sense. But yeah, at the end, the problem is that companies want money. And that's tricky, right? Because if you want money and you know that doing kind of tricky things with AI, you can get more and kill your competitors, you somehow will try to do it. And a lot of scandals would come out.
One thing we are trying to do in the guidelines we are working on right now is to give everyone the right questions to ask. And actually, the most basic element we identified, everything should start with is, what is the actual purpose of my product, right? What is this used for? And yeah, we kind of realize that, in today's world, you're maybe an engineer at Facebook or Google, right? And you're working towards improving certain metrics. And to you, it looks like you're actually improving the user experience, right? But if you look back and look at what is the purpose of the product and project, and why is it actually built that way, and why am I doing that, that actually helps a lot. And yeah, we're basically developing like a catalog of questions like this, like, does it actually make sense? Am I distracting my users or not? Are there more intelligent ways to maybe design the same thing that are better for the user long term? And then, of course, on the AI side, we have questions like, am I introducing any discrimination or bias? That's something people should really check for in every step of the process. And then also, of course, very importantly, what we think, are we actually empowering our users to do more, or are we taking decision power away from them? I think it's a very important decision to look at, because a lot of technology today is trying to help you to have a better life, but in the end, if it makes all the decisions for you, it's not empowering anymore. And that, of course, is negative in the long term as well.
There's this concept of a sort of net positive effect that you should basically consider when you're building out your. It's not just AI; it's any technology tool, right? Like this conversation could be extended just generally to modern technology, but you should always consider what is the net positive effect and what is the cost that I'm putting on society for this. And there's a super interesting exercise that MIT is doing, which some of you may have heard of. It's called the moral machine, which is about self-driving cars, but it's an exercise to try and determine where the lines are and try and determine it by examples. It's sort of like building a data set where they pose you with difficult decisions, like, oh, there's a dog crossing the road. Should the autonomous car swerve? Should it run over the dog? Like, is it better to kill 2 people that are crossing the road or 2 people in the car? It's super difficult questions, but it's questions that help define where the line is. And in many cases, I think, going back to what Jan said about data, like all of our ML in one way or another is trained on data that was generated by human intelligence in one way or another. And like those lines are sort of blurred in human intelligence as well, not just in AI. So even just determining where the moral boundaries sit is a difficult exercise in itself, let alone defining those and applying them to a newly designed AI.
It's interesting that you've commented that a lot of these things apply to all sorts of technologies, and that kind of leads to the next question. There have been some ethics guidelines out there before in other areas in engineering in general, and are there some models that we should use in developing some kind of guidelines for ethical AI engineering? And what would you, I guess, what guidelines are out there that you would take a look at?
What a difficult question. What a difficult question. Yeah, actually, the thing with guidelines is that people can read them and don't use them. I'm more of the so my thoughts go more in the direction of having some kind of counselor professionals that needs to make sure that technology is safe more than having guidelines. Guidelines are okay, and there should exist something. But wow, how difficult would it be to make guidelines about the whole world? Because we are talking about something that can read, can view things, can talk, can interpret a lot of super broad different kinds of data. How do you write guidelines? So I think we enter into the philosophical world with exactly what is good, what is bad. So definitely at the end, the question is we need to do things for good. We need to be sure that our things are not doing bad. We will definitely have controversial questions. Are we killing the dog, as Jan said, or are we killing the people inside of the car, or are we killing this grandma on the other side? This is going to be something difficult, and we cannot forget that we are talking about a black box. We are talking about something that obviously is not totally a black box, and people working in that, we know that it's not 100% a black box. We have a lot of control inside of that. But wow, so so answering quick for that, I think we have to do that, but it's going to be super difficult. And it's going to be something more philosophical than actual engineering. But yeah, we do need to do that.
I think ultimately it has to be a lot more about education and how we approach engineering than trying to define what is good and bad. I think what is really interesting is that we are building frontier technologies today, and they're kind of operating on the edge of values, that we have in society. And by doing that, they're ultimately changing society as well, and actually at an ever-increasing speed, it seems. So I think the first step is to really educate engineers to kind of understand that responsibility, right? Because they are kind of defining the future values of society and where society will move as well, right? Right now, it's basically just going somewhere because no one really thinks about it. And I think, as I said earlier, like in the end, it's more a set of rules and a certain approach to engineering that makes sure that these kind of questions are taken into account, right? The same way you have automated builds and tests, right? You can also have a part where you sit together and check, what is actually the impact of this? How does this work out when it scales? Are we maybe discriminating certain users? These are just questions that are not asked today. And if we wish just to start doing that already, I think it would improve things a lot.
Yeah, I mean, that's actually a great point. Like the biases that we have in the data sets that we create, a lot of the time are implicit. We don't even realize that they're there. But there's a very high risk that a model will pick those up. And so we need to be very careful when we design these. I think what could probably be a good solution is what I've seen in trading firms. So there's a set of guidelines, there's a set of regulations that are sort of like not intentionally vague, but some of them are intentionally open-ended. And then every trading firm has what they call a compliance officer, whose job it is to make sure that those guidelines are being respected. And so I think the point that Eduardo was trying to make is that you can't really make guidelines that go case by case, right? You have to be vague so that you're covering everything, but then you can sort of add the responsibility on everyone who's building some AI to then do their own interpretation to the best of to the best intentions. And that has kind of worked out. I mean, in finance, it's worked out because if you get that wrong, the penalties are super high. I don't think using a stick is necessarily the right way of doing things, but it's one approach of having someone whose job it is to interpret what are these guidelines and how do they apply to what we're doing as a business, could be the right way of doing the interpretation of what's best for humanity.
So we've had a couple of ideas here about who would make those guidelines, and I'd be like for you all to expound a little bit. It's in one case there's maybe some regulations or there's compliance within a company. What about from a political leadership point of view of who would maybe set some kind of guidelines, or is it crowdsourced from the engineering community? Some ideas there. Who should be responsible for defining the ethical standards and adherence to those standards in an engineering endeavor?
Yeah, I think for that, definitely for sure, should be an independent organization that doesn't have to do anything with countries or companies or anybody. Definitely they need, inside of the companies, there should be someone to take care of that, but there should be an international organization that takes care of that, like somewhere like the United Nations, because we are talking about something with a crazy potential to do good and to do bad. That's the amazing thing, that it can do the best good ever. It can solve a lot of human problems and give us a lot of extra abilities that we never had before, but it can do also really bad. From my point of view, we need to test it as cars are tested. As we said before, there's some sort of black box of what it happens. So we cannot just test the components inside. We need to test it like in crash tests. There should be like an association that takes the software. So this software should be provided to this group, and they should be able to test if there are biases in the usage, what happens in under crazy conditions, because crazy conditions will occur. That for sure. We are talking about the day that, so nowadays with Facebook using their AI, we are talking about more than 1,000 millions of users that they have, that they are applying this AI. So crazy situations will occur daily. So yeah, we do need a kind of a association that tests it really deeply, that companies, that what companies deliver is good enough. Because if not, we have the possibility that companies, they try to deliver way too quick, way too fast, and at the end what happens is that the quality is not good enough, and you have a car that crashes, or you have things to detect depression that tells you that you're depressed, and so brings you to take medicines when you don't need them, or the other way around. So yeah, so failing in both directions is really bad. We have to be sure of that. And companies, we know how they work right now, and it's really good how they do these agile things and all this, that they try to deliver quick without super crazy testing, but it's dangerous. Yeah, we all remember when Google was tagging black people, so African American people, as monkeys. So that was crazy. They did that, so the Google's algorithm mixed those people, and that was something horrible. That should have never happened with a proper testing, but they tried to deliver the software way too quick. So yeah, in my point of view, there should be a central association, totally unrelated with companies or governments, that really hard test those models, and determines if they're good enough, if they're ethic enough, or not. And if not, you send them back and you cannot use them. And in my point of view, that's the only way to be sure that companies deliver proper software. And the cool thing is that if you press them a lot in this direction, at the end they will make sure it's ethic enough. So at the beginning, maybe not. They try to do tricks to be accepted, but at the end, they will do it good. And that's what we all want as users.
I think Eduardo also touches on an interesting point here, which is that software engineering is somehow one of the very few disciplines where in engineering, where there's basically no consequence for what you do, right? If I design a bridge and it's statically really not sound and it breaks down, right, then I'm actually responsible for that. In software engineering, we don't have that. So I think that eventually, but that's many, many years down the road, right, society will catch up a bit and we'll have some form of regulation in that regard as well, coming from the governments. But I think that will take some like learning in society, and probably some things will have to break, and then people will kind of wake up from that. I would say today still the main responsibility, is on us to implement these and to build good technology. So it really has to be everyone, right? If you're an engineer, if you're a designer, if you're a project lead, a manager, if you actually own a company, you should make sure that in all your processes you have, someone always steps back and asks themselves, are we doing the right thing? And also often, are we making it transparent to our users, right? Are we maybe not just having a black box, but giving them some choice and making them understand? Because a lot of it is also that, in society today, everyone interacts with these systems, right? And everyone gets, as I said at the beginning, a slice of the world presented, right? But it's not transparent. And again, to make these things transparent, right, that has to be the responsibility of the people building it, because they're the only ones who understand it.
I think, to touch on what Eduardo said at the beginning, which is there should be an entity that comes up with the guidelines that's independent of any country. I definitely agree on that point. I think if we're lucky, any government will be 5 years behind on the technology, and that's the good ones. So there are organizations that already exist that are perfectly positioned for doing something like this, like the IEEE. The IEEE have several conferences on machine learning and AI. They're at the top of publishing. They have all the network that they need to actually build the right guidelines. And I think there is some internal effort going on to get to that point. What then is missing is that, so if something like the IEEE, and it doesn't necessarily have to be the IEEE, but I'm using it as an example, if they come up with good guidelines and sort of a manifesto or something like that, then there needs to be an enforcement layer which introduces the responsibility, right? We can't necessarily rely on the goodwill of people, because 99%, like 99.99% of engineers are well-intentioned, and if you give them a manifesto of goodwill or guidelines, they will generally adhere to it. But there's always that 0.01% that won't, either intentionally or not. And there needs to be a way of enforcement. So I think the perfect situation in my mind right now is if there's a set of guidelines that, say, the IEEE puts out, and then local governments, like local country governments, ensure that these are applied either via a compliance mechanism or a certification mechanism, which is actually very interesting. I think putting the burden of certification at the beginning might really slow down progress. So you might want to find a mechanism that's sort of halfway in between. But there could be a way of not slowing down progress too much and still having that guarantee of following these guidelines.
Thank you. A number of people have touched on this idea of the black box. And first of all, I'm not sure if you mean black box from the user's point of view, excuse me, or a black box from the designer's point of view. In some cases, if you have an AI learning and being trained from data, whether it's reinforcement learning or supervised, but especially something like AlphaGo, I don't think that the designers really know exactly how it's thinking. So how can we provide transparency for something like that? And what requirements can we put to provide transparency for some of these black box issues?
There are definitely, yeah, this approach of the black box is something really, really traditional. You somehow know what is happening inside. Definitely AlphaGo, it's super advanced, and not only AlphaGo, but a lot of other scripts. But at the end, I believe, so if there's something that you cannot fully see how it works, you need to crash test it. And so really companies should definitely for sure so it should be mandatory for them to share this software with someone who tests, so someone, not definitely not one person, but like with one organization that is totally external and really, really deeply test that under all circumstances, because it's a black box. And yeah, there's no way. So at the end, you have inputs, outputs, and magic happens almost. So yeah, definitely. You don't need a good organization, but that's also a tricky part. You cannot have any organization. You cannot have someone that is influenced by big companies, because that's I can imagine that happening in lots of countries. They would try to put inside people from Facebook, Google, and even from governments to be able their companies is the one developing the faster, because as Jan said, so doing a lot of regulations or things like this could slow down the progress. Even it's okay. So maybe we don't need to run that fast, because running that fast in a wrong direction is really bad. It's even worse than going a bit slowly or in the right direction. So yeah, from my point of view, crash test and crash test from an independent organization for sure.
I just have a problem with the notion that we don't understand AI as engineers, because I mean, ultimately it's machine learning. It's a discipline that has been around for a very, very long time. And we understand really well how, for example, biases get introduced in our data sets. I think the issue today we have is that most people just take some data and basically say, oh, well, let's see if we get something out of it, and tell it to just optimize for a certain metric, and then find a local minima. That's kind of it, and then they ship it, right? And at that point, you know, neither the input nor the output nor the optimization parameters have actually been really checked. I think there's a great XKCD comic, which is basically a guy steering in data, and he's like, oh yeah, I'll just move it around until I get something that looks good on paper. And I think we can totally, as engineers, understand how these work. And not only that, then also take it one step further and think on what's implications on society, for example, are. It's just that today we don't do it. And a lot of us do that. I guess sometimes it seems a bit magical, and I think it's also sold like this a lot, right? The big tech companies have been very big recently in like selling AI to the public, right? It's this big marketing thing. And now people think that, you know, Alexa is a real person, or at least children think it. But ultimately, right now at least, right, it's still fairly simple to understand. And I think we should really take that into account when we design these systems. It's not rocket science. It's complicated. These are complex systems, but we understand them well. And I think saying that the engineered Facebook who optimizes for a certain metric doesn't understand the underlying systems, or the deep learning team at Google would also do them some disregard.
So I definitely agree on the point. Like, we have a lot of tools that allow us to do introspection into any of the AI models that are used nowadays. There's also a lot of effort that's going on in research. And so, like, anytime you say, oh, deep learning is a complete black box, Jan LeCun will get super angry and tell you off. And it's I think it's very important to sort of distinguish the perception that it's a black box and we don't know how it works, but actually we know all the mechanisms inside it. We know how to reverse a lot of the information in those models. And actually, I think it kind of is like rocket science in the sense that there is a lot of math. We do modeling of what happens in, call it the rocket engine. We don't know how every single molecule of oxygen is moving inside the engine, but we know exactly how the input affects the output, and we know how to turn the valves. And I think there's a lot of this not knowing why something happened boils down to not putting enough effort in understanding what the model is doing, rather than not having the tools. Because there are certainly a lot of tools out there that help us. There are always some nuances that come up that are completely new and we don't understand. Like a couple of years ago, it was adversarial examples, which are like, okay, that's great and interesting, and there's new discoveries. But that's also true of any other discipline. And so I think we do have a lot of tools to understand, at least to the point where we sort of have the ability of introducing barriers to ethical or unethical uses. And we just need to make sure that we use those tools.
Thank you. So it comes down to understanding how your algorithms are really working. And although I agree that Google engineers, I'm sure, know exactly how their algorithms are working, since this is becoming very accessible to everybody, is everybody understanding how it's all working, and what kind of educational things do we need to take into account? Let's see, how do we ensure that emerging generations of AI practitioners, especially the new ones, understand the ethical implications inherent in the development and transformational technologies that they are learning? For example, there are some ethics classes that are being, or modules being introduced. I know that the Udacity's data science module does include some. Where does education fit into this? I think you've all touched on it a little bit, but could you expound a bit? Thank you.
I mean, education is kind of the main thing we are trying to do as a GTC here. We kind of see it in three aspects. The first one is actually the public. I know we're talking about engineers today, but everyone who becomes an engineer was not one before, right? And today the public has absolutely no idea about what this technology is doing, and often they don't even understand how certain decisions are made. So the first step is really educating the public, and we actually do that with like a series of news articles and interviews and things like that. The second one is educating the engineers, and I think it's great that Udacity is adding things like that to the program, and I know that universities are doing it as well. We have companies that actually ask us basically for advice, and we'll hopefully be able to like point them to the guidelines that we're developing once they're finished. And generally, I think it just has to become accepted everywhere, that it's just a part of what we do, and not only for the specific sector, but I would even say all of software engineering, because today actually most products kind of touch on it, right? Even if you want to just build a simple device or a simple application, usually there's some AI and machine learning involved. And thirdly, it's actually educating the governments, our politicians. They're today very much behind the curve on these kind of questions. And I think it's really important to have initiatives that kind of help everyone get on the same page. Like you can't do this without having everyone in it.
So I think education has a big part to play. I'm going to go back to my statement that it's not just AI, it's all of modern technology. But like if we look at things like civil engineering, medicine especially, but like biotechnological research, all of these things that are not AI, they also have the same ethical issues, right? And at some point along the line, students are taught about the ethics of doing research on microbes all these things, or viruses. And it's important that we have that in the learning process. So I mean, it's great that Udacity has introduced this, because it's important, and it's also a way of giving students the knowledge of what things do I need to think about when I'm thinking about ethics, right? It's easy to think about, oh, am I doing things like discrimination? But there's also other things, like there could be like third layer indirect effects about something that you're building that you're not explicitly thinking about. And so giving the training to think, 2 steps down, 3 steps down, like who am I impacting? What sort of effect will it have on, say, communities or anything like that is very important, and it has to be part of the education process. I think there's also a responsibility from academia in sort of leading by example. So I'm still very heavily involved in research and academia, and I think there's an important role that academia plays by sort of leading the research. And there's actually a good, so it's not all bad, right? There's a good example where there was a paper published on trying to determine if someone was going to be caught committing a crime based on a picture of their face. And that paper was immediately removed, and they basically got a public lynching for even trying to suggest something like that. And I think it's great that we're sort of doing things at even the academic level by sort of taking down these bad examples of uses of AI, because that means that we're setting the right culture and the right environment for everyone else to follow.
Yeah, I think we need to be, so we are scientists at the end, we are engineers and scientists, and we need to be transgressors with this thing. But definitely, I would go even a step behind. So it's not only about what you learned in school, so in the university, or what you learned in Udacity. So it's amazing that you already include that in the course, but it's something that people should learn from at home when they're kids. So at the end, we are talking about manners. So gender biases starts when you're a kid. You have to start working with your kids. It's something that we cannot complain now that we are, oh my God, this algorithm is super biased. Society is biased, and it's our responsibility to fight against that. So we have to go to the very, very beginning and teach kids how to be unbiased. And from this on, they will end up being engineers, and they will end up being people that they do good, because at the end, engineers are people. We don't have to forget that. That's something, yeah, but sometimes people forget that there's like some kind of person that sits behind a computer and do amazing stuff. But no, we are people. We do our people. We cry. We do our thing, and we agree it as well. And that's the thing. If you have, how to say, people with bad manners, they will code with bad manners. So at the end, it's a reflection of who you are, how you do business, how do you do everything. So we definitely need to go one step behind. We don't have to forget that we are humans and we like to go always one step farther. So, but we have to have our foundations really well set. So yeah.
I think ultimately, maybe to answer this, it's on us as engineers to lead that effort, right? And I think everyone kind of woke up from the last 5 years and saw what happened. And I have a citation from end of last year from Shimad Prajapati, who was like a very high-level executive at Facebook, and he said, "I feel tremendous guilt. I think in the back recesses of our minds, we knew something bad could happen. But I think with the way we define it, it's not like this. It literally is at a point now where I think we have created the tools that are ripping apart the social fabric of our society works. So I don't want to be the engineer 5 years down the line who has to say that about their own work, right? And I don't think anyone in the audience today wants to be that. So it's really on us to lead that education effort on all levels and to ourselves start implementing this, because otherwise 5 years down the line, we'll have the same result. and no one will be the wiser.
Thank you. We have some questions from our audience. So I'm going to read the next one. Katian asks, great values and interests. One way to ensure that technological development represents benefits for society is to bring the interested social groups to participate in the debate. How do we ensure the participants of the relevant groups, the participation of the relevant groups? Anyone want to take that one?
I think that's also, again, of a cultural thing that we have to solve from the beginning. So everybody should know that they have the same possibilities to go everywhere, and we have to help people to do that. It's a pity that, so I see now I'm 32, and all my surroundings are having kids. Everybody's having kids right now. And I see how people treat them differently. And it's crazy to see this bias, this how you tell some kids that they are beautiful and others that they are smart or fast or strong. And also that happens with race, with religion, with a lot of things. We are the first generation that we have almost everything solved, and we are the responsibles of that. There should be no other organization, nothing else. We are the ones that we have to sit down and say, hey, we have to try to force our data to be unbiased. That's a bit weird, okay, because we don't have the same how to say, if you collect data, you won't have the same number of samples of each kind, and then you will have to do kind of tricks there. But it's our responsibility to make technology that is fair. It's definitely our responsibility. Imagine that, I don't know, there's a car, crazy things, but that happened before, and it's something really, really easy. Imagine that you have a self-driving car, but it is voice activated, and it doesn't recognize my accent. That's something kind of crazy, but that happens. And it's something that maybe when I'm talking with Siri, I'm not worried because I can type. But if I'm in a car, I want the car to understand me. So we do need to do this thing. For example, in our case, it's totally a bit unrelated, but with malaria, that we are working daily with malaria, there's a lot of ways to do this malaria preparation, and we have to train our device to work with all of them. And it's way, 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 way more work. It's making everything harder, way harder. But it has to work like this. And every device should work like this at the end. I don't totally know if that was the answer that you wanted, but yeah, that's what I had in mind.
Okay, let me give another question. Maybe someone else will take it. Let's see here. We have, is it possible to define in general what is good AI when the applications of AI extend beyond national and cultural borders? Jan or Alan, you want to take that one?
It's a hard one. I think you already opened the discussion, right? We'll never be able to have one definition of good or bad, right? And so in the end, it's something you as an engineer have to decide yourself, right? Do you think for yourself it's good? I think what should be important for someone working in software engineering in an AI is to actually ask themselves that question and come to a conclusion, right? Because I think what is really lacking is that today we don't do that. So just by taking a step back and looking at the product you're building and think about the impact it has, and whether you think that is good or bad, you're only doing the right thing, right? And then in the end, it's down to your own judgment, you know. But just by asking the questions, you're only doing a lot of good, actually.
Yeah, I'd like to add to that point, because I think a lot of time, like, we ask these questions of AI, but if you just remove AI from the question, like, there are a lot of things that are usually done from a technology point of view that aren't necessarily good. And so we should really be asking that question all of the time, not just when we're building AI, I mean, it's great that, in a sense, it's great that AI has put this aura of terror around it, and so we are at least asking the question in some cases, but really we should be asking it all the time, right? Like the first person that invented the machine gun should have really asked themselves, like, do I really want to do this? Like, is this a good idea? And so we need to sort of keep asking those questions. And the answer is not a quantitative one, right? You can't say, oh, this is 0.3 good and this other thing is minus 0.2 bad. It's more of an evaluation with respect to what's the positive effect, what is the cost, what boundaries are we putting on this thing? And it's always something that has to happen at the design phase, right? You should always ask yourself about any tool that you're building, not just AI. Like, is this a good thing or is it a bad thing that I'm building?
Okay. Looks like we're about out of time, so we're going to go ahead and wrap up. And we're helping out and giving our audience a lot to think about. I'm going to hand it back to Chris, who has a few final words, and I'll give it to him now. Thank you all very much for being here.
Once again, for me as well, thank you very much to all our panelists and to everyone watching for tuning in from around the world for this discussion. I was following along in the live chat on YouTube, and there's intense discussions going on there on this subject as well. And there's more questions, unfortunately, we do not have time for. I wanted to say that this webinar is recorded, and I'll be sending the link to the recorded webinar to everyone who registered for the webinar in the first place. So feel free to watch it again and to share it with your friends. And if you're interested in learning more about the technologies that we talked about here today, machine learning algorithms and data science and artificial intelligence, then do check out Udacity's School of Artificial Intelligence, where you can enroll in these nanodegree programs and learn the technologies underlying the discussions, and also, as we said, take a module on the ethics of machine learning. And also join our Udacity Europe Facebook group. Just search for Udacity Community Europe, and we can have the discussion continue there. It's a never-ending discussion that will, I think, for a long time yield more questions than answers. And I'm very glad that the panelists and viewers here today are kicking this off and are a great part of shaping this discussion. So once again, thanks to Dana for moderating this. And thanks to the panelists, and thanks to all of you for watching. Until next time.